today we will discuss about the errors in measurement. Last time we have discussed that what are the measurement or the type of the measurement, how we do the measurement. Now today in this lecture we discuss what are the errors occurred in the measurement of any reading in the device. So everything experimental research is built on measurement. So many of the great scientific advancements would not have been possible without ever increasing standards of measuring precision. So qualities are measured using international measurement and are completely accurate as compared to the others, and on the basis of that we take all the readings of an instrument. Measuring is done in the same way as the vegetable vendors do, like be comparing as the known amount of the weight to the unknown amount of the weight. Whenever we buy something, that we compare the known amount of the weight with the unknown amount of the weight. So any calculation contains a level of uncertainty which is referred to as the error. So when we are having just a uncertainty in the calculation, that will occur the error. So the error may occur during the procedure or even as a result of failure in the experiment. So as a result, no approach can have a 100% precise calculation. No instrument give the 100% precise calculation if we are working manually. The aim of every experiment is to determine a physical quantity as accurately as possible. Whenever we perform the experiment in the laboratory, then we try to get the accurate reading through the experiment, through the instrument. But every measurement, however, consists of some error that may occur due to the observer or the instrument used, or both. Sometimes we are not taking the properly, we are not just taking the readings properly, or sometimes there must be a error in the instrument. Means when we calibrate it, it not calibrate at a 0 or a null point. So there must occur an error in the instrument, or we get the reading, we are getting the mismatched reading, or we get the uncertain reading. So error may also creep in due to the small changes in the condition of the experiment, or due to various factors inherent in the experiment. So the measured value of a quantity differs somewhat from its true value due to the presence of such errors. Because of these errors, the true value something mismatch with the actual value, with the values we measure through the experiment. So there is a difference between the actual value and the measured value that represent the presence of error. So both the experimental research and the technology are built on measurement. So any measurement made with any measuring instruments gives a certain degree of uncertainty, and this uncertainty is referred to as an error. The difference between the real value and the estimated value of a quantity is known as a measured error, or we can call it as a measurement error. When we get the difference between the real value and the estimated value quantity, then it produces an measurement error. An error may be positive or error may be negative. So now easily we understand that error is the uncertainty in the value, or there is a difference between the real value and the estimated value, and sometimes error may be positive and sometimes error may be negative. So what is the error? error, if we talk about the definition of the error, the difference between the measured value of the quantity and the true value. True value means the reference value of the quantity is called an error. So, error is equal to, you see that is the formula, measured value minus the true value. So, it is represented by del A is equal to AM, that represent the measured value, and minus AT, that represent the true value. So, del A is equal to AM minus AT. Now, we do the classification of the errors. All measurement can be made without the perfect accuracy. That is, the degree of error must always be assumed. In reality, no measurement can ever made with the 100% accuracy. It is important to find the actual accuracy, and the different type of errors can be occurred in the measuring instrument. So, errors may arise from different sources and usually classified as follows. Like number 1, that one is the gross error. You see on the screen that this is the classification of the errors. Number 1 is the gross error, second is the systematic error. Now, the systematic error again of the 3 types. First is the instrumental error, second is the misuse of the instrument, third is the loading effect. And the instrument errors again divided into 3 types, like inherent shortcomings of the instrument, second is the minus of instrumental and loading effect. So, the systematic error of 3 types: instrumental, environmental error and the observational error. And instrumental error again 3 types: inherent shortcoming of the instrument, misuse of the instrument, loading of effect. And third type of error is the random error. You see on the screen there is a classification of the error, types of the error. It is again divided into the 3 types: random, systematic and the gross. Again the systematic again divided into 3 types, and this instruments error again divided into 3 types. So, this is the classification of the error. First we discuss the gross error. The main source of gross error is the human mistake in the reading and using the instrument, and in recording and calculating the measured quantity of the reading. Like if you are measuring the reading, as long as the human beings are involved and they have the grossly misread and the scale reading, then definitely some gross errors will be occurred in the measured value. It is because of the human mistakes by taking during the time of the reading. Like example, if we would take due to an oversight, experiment may read the temperature as 22.7 degrees centigrade while the actual reading may be 32.7 degrees centigrade. This is an example. He may transpose the reading while recording. For example, it may read 16.7 degrees centigrade and the recording is as 27.6 degrees centigrade as an alternative. So, sometime the human mistakes by taking the readings will represent the gross error. So, the complete elimination of the gross error may be impossible. One should try to predict and correct them. Some gross errors are easily identified while others may be very difficult to detect. So, gross errors can be avoided by using the following 2 ways. First way is the great care should be taken in reading and recording the data. Second, 2 or 3 or even more readings should be taken for the quantity being measured by using the different experimenters and different readings point, different environment condition of the instrument to avoid re-reading with the same error. So, it is suitable to take a large number of the readings as a close agreement between the reading assures that no gross errors has been occurred in the measured value. The next type of the error is the systematic errors. that systematic errors are again further divided into three parts. Number one is the observational error, second is environmental error, and third is the instrumental error. So, systematic error, this is the flow diagram, that is the we represent the observational error, environmental error and the instrumental error. If we talk about the environmental errors, then these errors are arises due to the following three reasons. Number one, due to the inherent shortcoming of the instrument. Number two, due to misuse of the instrument. And number three, due to the loading effect of the instruments. So, these are the 3 points. Because of that we are having the instrumental error. Inherent limitations of the device, abuse of the apparatus or effect of loading will affect the readings, or we just actual result we will not get because of the instrumental error. So, first is the inherent shortcoming of the instrument. These errors are inherent in the instruments because of their mechanical structure, due to the construction, due to the calibration or the operation of the instrument or the measuring devices. So, this is the inherent in the instrument. These errors may cause this instrument to read too low or too high. So, example, if you take, if the spring used to producing the controlling torque of the permanent magnet instrument has become the weak, so the instrument will always read high. If the permanent magnet instrument has become weak, so the instrument will always read high. So, error may be occurred because of the friction, hysteresis or even the gear backlash. So, elimination or reduction methods of these error, if we do the recalibrate the instrument carefully. So, procedure of the measurement must be carefully planned. So, substitution methods against substitution method or the calibration against the standard may be used for the purpose. So, correction factor should be applied after determining the instrumental error. First we check the calibration of that particular, or we just put the instrument with, first we calculate the error of that instrument, after that the student should take the reading, so that the error may be reduced in the further readings. So, number 2 is the misuse of the instrument. In some cases, the errors are occurred in the measurement due to the fault of the operator, that of the instrument, Now, sometime misuse of the instrument has been done, means the operator is using the instrument and he is not or she is not taking the reading properly. A good instrument use in an unintelligent way may give the wrong results. So, example, if we use the misuse of the instrument, may be failure to do the zero adjustment of the instrument. So, we first, if it is not possible to do the zero adjustment, then we start the reading. After taking the first reading with that error, then we start taking the further reading. So, poor initial adjustment using leads to the too high a resistance and the ill practices of the instrument beyond the manufacturer's instructions and the specification etc. Third type of the instrumental error is the loading effect. The errors committed by the loading effect due to the improper use of an instrument for the measurement work. In measurement system, loading effect are identified and corrections should be made, or more suitable instruments can be used. For example, well calibrated voltmeter may give a misleading, maybe false voltage reading when connected across a high resistance circuit. So, loading effect means errors committed by loading effect due to the improper use of an instrument for the measurement work. And the same voltmeter, when connected across a low resistance circuit, may give a more reliable reading, dependable or the steady or the true value. So in this example, the voltmeter has a loading effect on the circuit and altering the actual circuit condition by measurement process. So error caused by leading effect of the meters can be avoided by using them intelligently. Sometimes, if as we have taken the example of the voltmeter, sometimes it will not work for the high resistance, but this voltmeter will be suitable for the low resistance. If someone used it for the high resistance, then it will be damaged, or it must not be calibrated, or it will misleading has been done, so it will not give the proper reading. So that voltmeter is used for the low resistance, then it will give the good reading or the true value or the more reliable reading as compared to when it is attached to the higher resistance. So voltmeter has a loading effect on the circuit, so altering the actual circuit condition by the measurement process. So errors caused by a loading effect of the meters can avoid by using them intelligently. The next type of the error is the environmental error. Environmental error occurs due to the external environment conditions of the instrument, such as effects of the temperature, effect of the pressure, effect of the humidity, effect of the dust, vibrations, or the external magnetic or electrostatic field. So elimination or reduction method of these undesirable errors are: arrangements should be made to keep the condition as nearly as constant as possible. So if we take the example of that, we will take the example, the temperature can be kept constant by keeping the instrument in the temperature controlled region, so that the reading will the instrument will give the proper reading, we can get the good measurement. The device which is used against these environmental effect, example if we take, then we say that variation in the resistance with the temperature can be minimized by using the very low resistance temperature coefficient of the resistive material. So it will work properly. Employing the techniques which eliminate the effect of these disturbances, for example, effect of humidity, dust, etc., can be entirely eliminated by the tightly sealing the equipment, and it will give the good result. The external or electrostatic effects can be eliminated by using magnetic or electrostatic shield on the instrument. Next type of error is the observational error. So there are many sources of the observational error. If you take the example, then the pointer of a voltmeter rests slightly above the surface of the scale. So thus an error on account of parallax will be acquired unless the lines of vision of the observer is exactly above the pointer. We are talking about the manual voltmeter or manual ammeter. If the scale is not properly aligned on the actual reading, then we will not observe the exact reading of the instrument. So to maximize parallax errors, highly accurate meters are provided with mirrored scale, as you see in the figure, that sometimes if you are seeing from the wrong direction, you see the position of the eye on the above figure, left hand side you see that it is not on the actual, the needle is not on the actual reading, and right hand side you see that the value, if you are seeing above the needle, then you will get the exact reading. As you are saying, at the last figure you see on the bottom that the position of the eye on the right hand side, then there is a sum, the pointer reflection we will not get at the particular value. So the middle one, the right hand side picture is correct, where we are seeing on at the up position of the needle. So otherwise there must be a mismatch in the reading. When the pointer image appears hidden by the pointer, observer's eye is directly in the line with the pointer, and although the mirror scale minimizes parallax error. So, an error is necessarily presented though it may be very small, and when we see the line directly through the pointer. So we can eliminate this parallax error by having the pointer and the scale in the same plane as you see here on the screen. If we put it on the same plane, then we can get the good reading. You see the needle point is just at a particular value, at a particular scale. You see the above, there is a scale, there is a pointer, and this pointer is indicating the correct reading on the scale. So, the observational error are also occur due to the involvement of the human factors. It may be the human mistake, and it may burst of the involvement of the human factor. And for example, there are the observational errors in the measurement involving timing of an event. Different observers may produce a different result, especially when the sound and light measurement are involved. The complete elimination of this error can be achieved by using the digital display of output. In the manually, we get the mismatch in the reading, but this type of error may be removed or eliminated by using the digital display of the output. Third type of error is the random error. These errors are occurred due to the unknown causes or are observed when the magnitude and the polarity of a measurement fluctuate in the changeable random manner. The quantity being measured is affected by many happenings or disturbances or ambient influence about which we are unaware or lumped together and called as a random or residual error. So, these error caused by these disturbances are called the random error. So, these errors occur due to the unknown causes and are observed when the magnitude and the polarity of the measured fluctuate in changeable manner. Changeable manner means randomly it is changing. Since the errors remains even after the systematic error have been taken care, these errors are called the residual or the random error. Random errors cannot normally be predicted or corrected, but they can be minimized by skilled observers and using a well maintained quality instrument. So, these errors which occurs due to unknown sources during the measurement time are known as the random errors. Hence, it is not possible to eliminate or minimize these errors, but if we want to get the more accurate measurement values without any random error, then it is possible to reduce by the following two steps. Number one step is the take more number of the readings by different observer. Number two, do statistical analysis on the readings obtained in the step 1. So, these are the following parameters of the random statistical analysis. Number 1 is the mean, number 2 is the median, variance, deviation, standard deviations. We will discuss one by one in the next lecture. So, these are the statistical analysis and which reduces the random error. And this random error occurred instantly or because unknowingly. So, how we remove this? By that we will take by using the statistical analysis, and there are the various methods to get the statistical analysis that we will discuss in the next lecture. Thank you very much.